In this question, given that suppose f function f is mapped from a to b is a bijection. We know that bijection is nothing but this function f is a one-to-one function and onto function. So we are going to prove that f circle identity function is giving the function same function f. Inverse of the function f circle f function is giving the identity function. We are going to prove this one. In this IA means identity function, so which is nothing, identity function is nothing but the domain and codomains of the identity functions are same. Similarly, if I take the IB, so domain and codomain of the sets are the B sets, then it is also a identity function. Now we know f is the function from A to B. How to write the f inverse? Simply we can interchange the domain and codomain values. In this way we can write it. So now we are going to prove these functions. If any functions if both are the equal, if you see equal symbol is there, this is the one function, composite function is the one function. If two functions are equal, we are going to prove, we can prove by those domains of the two functions are equal and codomains of those functions, two functions are equal. If we prove this one, these two, we can say that those functions are equal. Okay, na? When we say the two functions are equal, those domains and codomains are equal, then we can say the two functions are equal. Now I'm taking the first function this side and second proof this side. Okay. Now first one. So A part proof I have taken here. So we are going to prove f circle IA is equals to f. We know the domain of this function is equals to the domain of this function. We are going to prove it. First I am taking the left side domain of the composite function. You know now how to write how to find the domain of the composite function. So domain of the composite function is second function. Okay, na? This composite function domain which is equals to the second function domain. Okay, domain of IA. We know that now you can see in the IA function. So what is the domain value? A set only. Okay. Now domain of the f circle IA, we got the A set. Now I'm checking the domain of f. Domain of f is A set only. Right. Both are having the same domains. Then okay. The domain, both the functions having the same domain, we proved that. Now we are going to prove the codomains also equals. We know that according to the codomain rule, codomain of any composite function, the first function codomain which is equals to the codomain of first function. Then we done na codomain of the function of composite function which is equals to our required codomain of the function f. Yes, this is true. Okay, now these two conditions true. We can say these two functions are equal. Then f circle identity function is always giving the same function. Similarly, this side B part also I am proving f inverse f. Now I am going to first prove domain of first f inverse circle f. What is the domain of f in composite function? The second function domain only na? I can write it. So composite function domain is nothing but second function. So this is the second function is this one. This function domains which is equal to this function domain. So I can write it domain function of f. Okay. We know that what is the domain function of f. F function we know that A to B. What is the domain value here? A set. We know that A set. Now I am taking the domain of the identity function. What is the domain of the identity function? IA, A only. So from these two I can say both the functions domain are the same. Now I am going to check the second case, codomains. Codomain of f inverse circle f. We know that which is equals to the whenever composite function codomain, the first function codomain which is equals to the first function codomain. That's why I can write like which is equals to the codomain of f inverse. We know that what is the codomain of f inverse? We know that if you know the f domain codomain, how to write the f inverse we know already. Interchanging this one. Now F inverse codomain. This is the F inverse. This is F inverse codomain is A. That's why what answer you got it? A. Now I am going to check the codomain of A. Codomain of IA. Sorry. Codomain of IA. I am going to check it now. We know that in the IA domain and codomain both are the only na. That's why here also I am getting the A set only. See this one. F inverse circle F codomain is also we got the A set, and codomain of I also we got the A set. That's why these two also equal. Remember, if F is any bijection function, we are going to use in the other problems also. Remember, so F circle with identity function F is only F inverse circle F, we are getting the IA.